Hey guys, today we're going to look at some problems in chapter 4, just a few. We're just going to do a few problems in chapter 4, and I'm going to concentrate on Python. A lot of people love Python. But remember, we're really using three different programming environments in this course. Sometimes I'm going to use Mathematica, sometimes I'm going to use Racket, and sometimes I'm going to use Python. I've noticed that the majority of the students who take this particular class, most of them are very comfortable with Python. They've used Python before, and that's why I've decided to incorporate Python into our course. And that's okay, but do not underestimate Mathematica and Racket because they're pretty cool too. They're pretty amazing too, okay? So you should try to give them a chance. Anyway, let's look at the first problem in chapter 1. Okay, so this is a divisibility question. Identify the numbers that are divisible by 17. So how do we know if a number is divisible by 17? Well, you have to use the mod or modulo function, and that in traditional programming languages like C and C++ and Java and Python, it's usually represented by the percent symbol. Okay, so here, let me start this over 1 second. I'm going to start this over. Let's see. Okay, so IPython. I'm using Python in my terminal shell. You don't have to use Python in your terminal shell. That's up to you. Whatever, however you're comfortable using Python, that's up to you. I like to use it in my terminal shell. You could also use it in something called a Jupyter Notebook. Okay, terminal shell. I mean, it's up to you. You have to kind of experiment and figure out, what's best for you. Okay, I'm just showing you what I like to do. Okay, it doesn't have to be what you like to do, right? Okay. My hair's a little messy right now, but that's okay. I just came back from a long, sweaty walk with my dog. Okay, so is 10 divisible by 2? It sure is, because 10 mod 2 is 0. Right? 10 mod 2 is 0. There's no remainder. So the modulus or modulo refers to the remainder of a division problem, right? So 10 mod 2 asks the question, what is the remainder when I divide 2 into 10? Okay? The remainder is 0, and if the remainder is 0, we know that 2 divides evenly into 10. Okay, so that's easy, right? Not a big deal. Okay, identify the numbers that are divisible by 17. Okay, so 68 mod 17. Okay, so we know that 68 is divisible by 17, so I'm going to check that off. And the next number is 84. Is 84 divisible by 17? No, 84 is not divisible by 17. 84 is not divisible by 17. What about 357? 357, is that divisible by 17? Yes, it is. Okay, so I'm going to check that off. And what about 1001? 1001 mod 17? No, that is not divisible by 17. And by the way, just for your information, the answer to these questions, okay, because we're doing mod 17, the answer is going to have to be an integer between 0 and 16. So the answer cannot be less than 0, and the answer can never be greater than 16. It's going to be an integer between 0 and 17, not including 17. Or you could say the answer is an integer between 0 and 16 inclusive of both endpoints, okay? That's important to remember because we'll need to know that when we start converting binary numbers to decimal and decimal numbers to binary, et cetera, et cetera. Okay. I don't think I'm able to check this answer, but that's okay. Let's move on. For right now, I'm going to skip over the proofs. We can work on the proofs another time. I just really want you to get comfortable with some of the number crunching problems and some of the programming stuff, okay? So we're gonna skip over that stuff for now. We will go back to it like in a week or a couple of weeks. Actually, hold on one second. Okay. Okay, why? Okay, 1 second. No, not yet. I mean, we could do that, but it's pretty easy. But okay, here we go. This is what I definitely want to do with you guys. Okay, identify the integers that are congruent to 5 modulo 13. So the way you would write that, you would write it like this. Hold on 1 second. Let me put my laptop on the table. Okay, so the way you would write that is like this. You would write, like for the first one, 103 is congruent to 5 mod 13. Well, we don't know that for sure yet. We have to check, but that's the way you would actually write that. 103 is congruent to 5 mod 13. Let's see if that's true. I think it's true, but I'm not totally sure yet. Let's try it out. So how do we put that to the test? It's going to be 103 minus 5 mod 13. Is the result 0? Is the result, oh no, yeah, no, it's not 0. So it is not, let me change that. It is not congruent to 5 mod 13. Okay. So we're going to skip that one. What about negative 34? Negative 34 minus 5 mod 13. Yeah, that's going to be equal to 0. Okay, because negative 34 minus 5 is negative 39, and negative 39 divided by 13 gives me a negative 3 with no remainder. The remainder is equal to 0. In Python, by the way, if you want to do integer division, you would do this. Okay, so negative 39 mod 13 is equal to 0. So we know that this is true. We know that negative 34 is congruent to 5 mod 13. And the reason is because negative 34 minus 5, negative 34 minus 5 mod 13. And remember, in Python, the mod function is represented by the percent symbol. That's going to be equal to 0. Okay, so that's what they're talking about, okay? So, 1 second. Here we go. What about negative 122? So, negative 122 minus 5 mod 13. That's not 0, so that's not going to work. And what about the last one? Let's see. 96 minus 5 mod 13. That's also equal to 0, which means that that's true. Okay, and we can check some of these answers later. I mean, I'm pretty sure it's correct, so don't worry about it, okay? Let's see. Not yet. Not yet. Let's go over some of these a little later on when you've gotten more comfortable with some of the basics, okay? Decimal to binary expansion. Now that's a lot of fun, but to do that you need to understand how to set that up. So we're going to convert this number here, 321, we're going to convert that into its binary representation. Binary just means zeros and ones, all zeros and ones, okay? So how do you do that? Well, you do it by setting up a recursive function in Mathematica or Racket or Python or whatever language you're going to use. Now you have to remember that base 2 means everything here is either being divided by 2 or modulo 2. Because, you know, the answers, you know, look at the possible answers that you have here. It's a combination of ones and zeros, right? It's a combination of ones and zeros. So the algorithm is actually pretty simple. The algorithm is very simple. So we're going to define a function. I'm going to call it base 10 to base 2. And we're going to have a number. I'm going to call it num. And then we're going to have an accumulator list that is going to contain the answers. And by default, it's going to start out with the empty list. Okay, the empty list. So if the number is less than or equal to 0. If the number is less than or equal to 0, then we're going to return the accumulator. Return the accumulator. Because once you reach 0, okay, or if you're dealing with a floating point number, which you really shouldn't be entering as an argument anyway, but if you're dealing with a floating point number, you know, I think the num is eventually going to be less than 0, but really it should be equal to 0. So if it's equal to 0, you've reached the end of the function. You've reached the end of the algorithm, and you're going to return the accumulator. Else, what are we going to do? Well, let's see. So what should I call it? The quotient, or I could just spell out the word. Quotient is equal to num integer division 2. Remember, that's integer division without the remainder. Okay. Remainder is equal to num mod 2. And then we're going to do base 10 to base 2, the quotient, and then the accumulator. Okay, one second. I have to make sure I'm doing this correctly. Accumulator plus the remainder. And this has to be returned. This is going to be returned. Okay, so let's see if this works. Let's see. So these are my 1s, my 2s, my 4s, and my 8s. So let's say I have 1 8, no 4s, 1 2, and 1 1. So that's going to be equal to 8 plus 2 is 10 plus 1 is 11. Okay, so that means that 1 0 1 1 base 2 is equivalent to 11 in base 10. Okay, ignore the phone. Ignore the phone. Okay, so base 10 1 second. I'm gonna wait a moment for the phone to stop ringing. It's really annoying. Okay, so base 10 to base 2 of 11 is equal to 1101. So base 10 to base 2 of 11 is equal to 1101. Okay? Base 10 to base 2 of 17 is equal to 10001. Let's see if that's true. 10001. So these are the ones, the twos, the fours, the eights, and the 16s. 16 plus 1, that's equal to 17, which means that 10001 in base 2 is really the same thing as 17 in base 10. And by the way, the algorithm that I'm showing you, it doesn't just work for base 2. It really ultimately works for any base. It works for any base, okay? So let's see. Let's work on some problems. The binary expansion of 321 is, well, let's use our function. Base 10 to base 2, 321. Just annoying, of course, when I'm in the middle of making a video. Okay. So the binary expansion of 321 is, base 10 to base 2 of 321 is, okay, so we have 100000101. Let's see, that's 1, 2, 3, 4, 5. That's 5 zeros. So let me see. 1, 2, 3, 4, 5. No, wait a moment. The way they're, okay, hold on a second. So 100000101. Yeah, the way they're, okay, you know what? Hold on 1 second. I don't, that doesn't quite make sense how they're showing it. Let me see something. Hold on 1 second. These are my 1s. These are my 2s. These are my 4s. My 8s, my 16s, my 32s, my 64, my 128, and finally, I know this is a little hard to read, 256. So actually what I have here is 256, 256 plus 4 plus 1. That doesn't seem quite right. That's 261. So we have a problem here. Hold on just one moment. That is a little bit strange. Hold on one moment. If number is less than or equal to 0, we have a problem here. Hold on one second. Base 10 to base 2 of 321. There is an issue going on here. Quotient, accumulator plus remainder. This should be working just fine. Hold on one second. Let me check something. So what if we were to do 34? Okay, change this to base 2. So these are going to be the 1s, the 2s, the 4s, the 8s, the 16s, and the 32s. So we're going to have 132, 1, 2, and everything else should be 0. Okay, so if we have base 10 to base 2, 34, zero, 1, okay, I think this, okay, so my answer looks like it might be backwards. Okay, hold on one second. So we have, if you look at this backwards, we'll have 1, and then 0, and then 0, oops, and then we have 0 here, 1 here. Okay, so it looks like, you know what, my answer is actually my answer is actually backwards. It's actually backwards. Oops. Strange. Okay. That's easily fixed. So we can go over here. Well, let me make sure. Hold on one second. Let me just check something. Reverse the list. 1, 2, 3. Okay, so reverse is not defined. 1, 2, 3. Could someone get that, please? 1, 2, 3. A is equal to 1, 2, 3. And then we have A reverse. Okay, Python, why is Python doing this to me? Okay. Oh, you know what? I have to call the function. So now we have 3, 2, 1. Okay. So we can actually, yeah, we can make, okay, we have to modify this function a little bit. Okay. So it's going to be, well, the problem, okay, so then we're going to say acc is equal to accumulator dot reverse, and I have to call the function on that list object. Okay, and then I would say return acc. Return acc. This is where Python gets a little complicated. You know, people think Python's so simple, but actually that is not necessarily true. So let's see, base 10 to base 2 of 34. Oh, oops. Base 10 capital T to base 2 of 34. So it's returning. Okay, so this is where Python is really annoying. I think this is going to return the none type. Okay, so hold on one second. Here. Return accumulator. Let me see. Okay, because, okay. Let's see. Type base 10 to base 2, 34. Good, it's a list. So base 10 to base 2 of 34. Yeah, so it's the reverse of what we had before. So let me make sure this is okay. So we have 1, 0, 0, 0, 1, 0. These are the 1s, these are the 2s, these are the 4s, these are the 8s, these are the 16s, these are the 32s. So 32 plus 2 is obviously 34. So this time we have the correct answer. This time we have the correct answer. Yeah, before the list was backwards. That was kind of strange. Okay, so oops. Wait a minute. Here we go. Okay. Okay, so let's try this again. Base 10 to base 2, 321 should give me 101 0 0 0 0 0 1. So 101 and then 1 2 3 4 5 zeros and then 1. That is really strange. Oh, I see. It's right over here. It's going to be, yeah, the way they're writing it is a little bit weird. So 1 0 1 and then 5 zeros, 1 2 3 4 5 and then 1. And that's correct. It took a little bit of work, but 1 0 0 6 3 2. Okay, so base 10 to base 2, 1 0 0, and what was that number? 632. 632. Okay, so that's going to be 1 1 0 0 0 1 0 0 1 0 0 0 1 1 0 0 0. So we have 3 zeros, 2 1s, 3 0. Okay, let me see. Let me see if I can shrink this down a little bit. Oops. Okay. And let's bring this up just a little. Okay, so we have, let's see, 1 1. You know what? I think it's going to be this one. 1 1. No, that's not it. 1 1 0 0 0 1 0 0 1 0 0 0 0 0 0 1 1 0 0 0. So that's going to be the answer. Check my work. That looks good. And the decimal expansion of, so this time we're going in the opposite direction, where we want to know the decimal expansion of 1 1 0 0 1. We could actually use our function, although to do that, I mean, it's a little, so here, okay, I have 1 1 0 0 1 base 2, and I want to know what is this equal in base 10. Okay, so think about it a moment. We could actually use our function. We should write a different function for this, but that's okay. We'll use the function that I already have. We're going to use, this function right over here, okay? So think about it a moment. So what if you have this number 1, 1, 1, 1, 1? Okay, these are the ones, these are the twos, these are the fours, 8s and 16s. Okay, what if you add up these numbers? So 16 plus 8 plus 4 plus 2, wait a second, plus 1 is equal to, so we have 16 plus 8 is 24, plus 4 is 28, plus 2 is 30, and then plus 1 is 31. So we know that the answer cannot be greater than 31. It's going to be less than 31. It's going to be less than 31, okay? Whatever the answer is, it has to be less than 31. So how would I figure that out? Oops, wait a second. Okay, so what I could do, is this. I could say, num is equal to 31. Okay. And let's see, how would I do this? Actually, no, we're going to start with 0. Num is equal to 0. Num is equal to 0. While num is less than or equal to 31. Okay. Let's see. Base 10 to if base 10 to base 2, if, okay, one second, there's a lot of noise going on around here. If base 10 to base 2 of num is equal to, oops, 1, 1, 0, 0, 1, if base 10 to base 2 of num is equal to 1, 0, 0, 1, 1, 0, 0, 1, sorry, 1, 1, 0, 0, 1, 0, 0, 1, print,
okay.
no, oh, print num, and then we can do break. All right. Okay, that's just continuing to run. So, oh, because we didn't increment the num. So we have to do that. So, one second. So we have to increment the num. So that's going to, because otherwise we're just going to get 0 is going to constantly be changed into base 2. So num, okay, go up in steps of 1, and let's see if this works. So the answer is 25. The answer that we're getting here is 25. Actually, we should have started with num is equal to -1, but in this case, it doesn't really make a difference. So we could do this again, okay? So start checking with 0, start checking with 1, start checking with 2, 3, 4, 5, etc., etc. Again, of course, the answer is 25. So let's see if that's true. Okay, so remember we have 1, 1, 0, 0, 1. These are the 1s, these are the 2s, these are the 4s, these are the 8s, these are the 16s. I have 16 plus 8 plus 1, which is 24, plus 1, which is 25. Okay? So therefore, we know that the answer has to be the decimal expansion of 11001 in base 2 has to be 25 in base 10. And that is correct. Let's just do one more problem, guys, and then we're going to end the video. What is the decimal expansion of 01101110101? And that's base 2. So same idea. So first of all, how many positions do we have? I have a relative who just loves binary arithmetic. Okay, so let's see. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me make sure I'm counting that correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so what if we have 10 ones? All right, so 1, 1, 1, 1, 1. Okay, that's 5. And then 1, 1, 1, 1, 1. Okay, so let me make sure I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the 1s, these are the 2s, these are the 4s, these are the 8s, these are the 16s, these are the 32s, these are the 64s, these are the 128s, these are the 256s, and I believe this is going to be 512, I believe. Yeah, because 256 times 2, 250 plus 250 plus 6 plus 6 is 512. So this should be 512. So if I add up those numbers, I'm going to get 512 plus 256 plus 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, and that's 1,023, okay, which is interesting because that's going to be 2 to the power 10 minus 1, which is also 1,023. So the answer definitely cannot be greater than 1,023. So I'm going to use the same approach that I used last time. We're going to do num is equal to -1. We could start with 0, but I feel more comfortable starting with -1. Because if you look at the code up here, at the very beginning, num gets increased by 1 step before you even begin the algorithm, so it makes more sense to do that. So this is how we're going to do it. Num is equal to -1. While num is less than or equal to 1,023, num plus equals 1. If base 10 to base 2 of num is equal to, let's see, what is that number? 0, 1. Oh, well, see, the issue here is the leading 0 isn't even going to show up anyway. There's a leading 0 here in your list. The leading 0 is not going to show up, so I don't think we have to worry about that. Okay, we don't have to worry about the leading 0. So it's going to be 11011. Okay, 1 second. Okay, it's going to be 1101. Okay, let me make sure. 11011. Okay, let me go back to the page. So it's going to be 11011. 11011, and then we have, wait a minute, 11011 and then 0101. 0101. So we're taking all of those integers and converting them to base 2. If that's equal, okay, print the num and then break, okay? 437 should be the answer. 437 should be our answer. And it is the answer, okay? So hopefully this gave you some idea of how to use Python to solve some of these problems. Remember what the while loop does. Let's do an easy example of a while loop in Python. Num is equal to, num is equal to -1. While num is less than or equal to 50, print, this is called an F string. Let's see. Is my favorite integer. Let's see, and that should be num. Oh, and you know what? This should increment. Empty expression is not allowed. Why am I getting that? Hold on 1 second. Oh, I see. I see what the problem is. Okay. Okay, let's put num in there. There we go. Okay, so we're going to start with 0. 0 is my favorite integer, 1 is my favorite integer, etc., and go all the way up to 51. But let's say it's interesting how 0 gets printed out. Oh, because we started with -1. We started with -1. And it's interesting how 51 does get printed out. And it's interesting because what's happening is num is equal to 50 and then num plus equals 1. So the variable gets incremented before the print, before the printout. So what I'm going to do, because let's say I want to eliminate 0 and 51. So let's say that num is equal to 1. And we're going to change this a little bit. We're going to do the print. We're going to do the print first, and then we're going to change the value of num. Okay, so we're going to do num plus equals 1, which means num is increased by 1 step. And this time I have 1 is my favorite integer, 2 is my favorite integer, 3, 4, 5, 6, 7, you know, all the way up to 50. Whereas before, it wasn't quite what I wanted. I had 0 to 51, and that's not what I want. I just want 1 to 50, okay? Hopefully, guys, this was helpful to you. This was a short video, but I hope it gets you going in the right direction with Python and with your homework, okay? Take care, and we will continue this at some point soon. Some point very soon, okay? Let me exit out of here, and there we go. And, oops, that's not what I want. Just make this a little, okay. There we go, guys. Okay, we will continue this at some point in the future. If you have questions, just email me and I will try to answer your questions, all right? Take care and have a great day. Bye-bye.